The bicycle helmet. Now, for many people, the key features will be such things as lightness, ventilation, comfort, protection, style, and colors. But the most important thing is you'll want all those things for free. But creating and making a bicycle helmet is a complex story of design, of research and development, of construction. There's lots of moving parts at play here. And let's not forget, the job of the helmet is to protect some of the fastest and most expensive people on two wheels, like back-to-back Tour de France winner Tadej Pogacar. No surprise then, when it comes to the whole business of marginal gains and headbanging, we find ourselves in a futuristic nightclub in northern Italy, where they reenact all kinds of traditions. Oh, sorry, that's France. Welcome then to Met Helmets in Morbegno, northern Italy, at the top end of Lake Como, twinned, by the way, with Llanberis in North Wales. Now, whilst we'll be spending some time with the smoke machine in Met's state-of-the-art wind tunnel a little bit later on, we begin our story in the headbangers room. So whilst I might joke about traditions, Met have expertise in product which is unlike 95% of brands. A deep production know-how, having pioneered many of the helmet making processes. This is the test lab then. Bear in mind that most eMTB helmets are designed on a computer, outsourced for testing before mass production in China. Wow, just look at the state of that. That's Vinny T. Vincent Toupon's helmet from a crash in Rampage. Now, during a time where we're learning more and more about concussions, it really is reassuring to know that people like Met have got us covered. Met is a small family business which was begun in 1987 by Max Gaiato and Luciana Sala. It's still family owned and run. Oh look, there's Achille Montanelli and his cousin Irene. Ooh, some cool stuff in there. I'm thinking of the big names that have used Met both now and previously. Obviously, you've got Tadej Pogacar in road, but then you've got the likes of Steve Peat, Martin Meis, Isabeau Corduria, Maureen Cabarrou. I mean, the ratio of big names to what's essentially a small family company is pretty crazy. What makes Met so special then is that they come from a maker's history and not marketing. At one time, it was all designed, tested, and also manufactured here in this valley. A very beautiful valley. It is then incredibly unique in that respect. Welcome then to one terrifying machine built into the gods and some willing participants. I want to point out that Met actually go through 700 real-world impacts on these helmets in the testing process, and that means actually destroying over 200 helmets. Achille, why on earth do you destroy so many helmets?
So first, consider that it's not mandatory. It's a specific Met protocol that we do to go further in the testing and certify the quality and the safety of our helmets.
Do all helmet manufacturers go through this process?
I mean, we can do that because thanks to our facility here, which is unique in the world, but I don't know about our competitors.
You're not answering the question.
I will say no.
Right, folks, here's some of the equipment. These are called anvils. So you've got a hemispherical, you've got a flat head, which is insanely heavy, and then you've got this horrible, what do we call this, the curbstone? The curbstone. I mean, that weighs a ton. And it's coming from a pretty big height. Right, these are some of the conditioning machines where the helmets are prepared before they go to the destroyer. Now, in some of these units, Met tests for heat, they test for water, they test for cold, and also for aging. And then they go to this machine. Remember, folks, that what we see here is many stages into the development process. But nice to see that a future helmet that I might be wearing is ready for the smasher. So next time that you're looking for something for free, consider the hard work that these poor souls go through on a daily basis. Right, the life of a Met helmet actually begins in here in the design room. Actually, it's more than Met because Bluegrass is also part of this company. Right, here's Lorenzo. Just going to pull up a chair and have a quick chat to them. So all you do is a bit of drawing all day?
Could be nice, but no. Just the first part of the project started with a drawing, a hand drawing, and then we move on the 3D modeling.
So you do this simultaneously? You do the same?
Yeah.
Okay, right. And what about, where do you get your inspiration from? I'm looking at your mood board here, I take it?
Yeah, here there are some mood boards, some previous projects that I made. You can spot some cars that are always in my mind.
Yeah.
But also nature, because we all ride mountain bikes here, so it's nice to go riding and maybe find something on a tree that can inspire something on a helmet.
So you've done your drawings, you've worked on your CAD design. What happens once you've kind of got a rough idea of that? What happens next?
Yeah, when we decide an idea that can be nice to see in the reality, we move on the other lab, where we have the 3D printed machine.
Yeah.
And we 3D printed the first helmet that we can put on and understand if it's good or not.
So I think that then is where I go to next. Here we are then in the 3D room, and we've got two prototypes. Seems to me that one is significantly heavier than the other. Matteo Tenni is the head of R&D. What have we got going on here exactly?
Here we have two different technologies of 3D printing. One is gypsum, it's powder. One is plastic, FDM technology. The purpose is different because for the gypsum, we work for evaluating the style, the design. For FDM plastic, it's more related to function, fitting, and we print after we fix the style with the gypsum version. We can use for fitting tests, we can use for overall evaluation in the laboratory, except impact, of course. But we can also use for drag evaluation or ventilation evaluation in our internal wind tunnel. Those are the machines. This is printing gypsum. Those are printing FDM.
Matteo, what makes Met unique in the design part of the process of making a helmet?
We started more than 20 years ago making numerical simulation to optimize the helmet structure. At that time, we were the first into cycling industry. We are still making this in order to make the helmet structure better and safer.
Okay, so Bluegrass or Met have closed on their gypsum prototype. They've now moved to plastic. It's going to give you a kind of example of the number of iterations which the company might go through before arriving at their final design. So we've got 5 helmets here. They might actually go up to 10 different designs before they get that final version. So what are they doing? Well, the key part of this process is looking at impact simulation. Met or Bluegrass can accurately predict 99% of the time what will happen in a crash scenario. Obviously, there's more than that. They're looking at ventilation, we're looking at airflow, we're looking at the fit of the adjusters, the shape and form of the helmet in general. And then, of course, they get to their final design, which they close. And at this point, they open the mold and they get a pre-production prototype helmet, which they can take down to the test lab.
But why do Met have a wind tunnel, you might well ask? Well, I'm lucky enough to be one of the first to experience it.
So we've now got a wind speed of about 30 kilometers an hour. I'm looking at the control department over there. Oh, here we go. Here we go. Okay, we're going to 37. 40. Okay, all right. 50. This is on like 50 kilometers an hour. Wow, massive differences. 64. Remember, this is half the speed of what this machine can do. Wow. Amazing. Amazing. That's such a great experience. Wow. Now, on the subject of testing, by introducing a piece of kit such as this wind tunnel, just, talking about performance, it enhances the conversation of performance massively. It's not just Tadej Pogačar. I've actually forgotten how to pronounce his name. Tadej Pogacar. I mean, it's not just Tadej Pogacar that gets, to get kicked like this. Your helmet has been designed in this wind tunnel for ventilation and airflow. It's it's definitely a moment in time for me, for sure. He's got a lot to answer for, that man there. Isn't it funny how the perception, the construction and the style of mountain bike helmets has changed since mountain biking was introduced in the late 70s, 1980s. I actually didn't start wearing a helmet until, 1987, which happens to be when Met started producing helmets here in Italy. It's funny to think that Steve Peat actually raced World Cups in a helmet such as this, but this is the Rome of today. Radically different helmets. Now, I know that production has now moved to China, but Met retain a huge technical know-how when it comes to making bicycle helmets. We're now going to show you some examples of what I consider to be like the matrix. These are the molds which are involved to making mountain bike helmets. One of the ingredients of an eMTB helmet is actually EPS. Now, EPS starts its life in cylinder form and then it gets transformed into a spherical shape in the manufacturing process. So think of it a little bit like popcorn. The second component part of a mountain bike helmet is the polycarbonate shell, which starts out life like this. What happens then, Achille?
Then it gets thermoformed to get the final shape of the helmets. Then we cut out the vents and the perimeter of the shell and we put it into the mold.
Now you say injection molding, does that actually mean like pumping the popcorn into the mold?
Yeah, basically we can say that. Yeah. Basically it's high temperature of the EPS injected and that's the process. And then it chemically bonds with the polycarbonate thanks to this silver ink at the back, which creates what's called the e-molding process.
So does that mean it's like, is it vulcanized? How does the EPS and the thermoplastic kind of link together?
It's really a chemical bond that it's done by the higher temperature into the mold during the process, which is called e-molding.
So you're cooking it?
Yeah.
Now, obviously, we've been talking about adult eMTB helmets today. The production process of kids' helmets is actually simpler, but as you can see, a modern-day state-of-the-art helmet is quite a sophisticated piece of kit. There's got to be lots of moving parts involved in the production of one of these, right?
Yeah, exactly. Basically, the complexity of the mold is given by the number of sliders into it, which the sliders are made to create the holes on the side, on the back, and actually ventilation that channel the air and not just like work as a chimney. So that's what makes it things.
So it's not like a cake mold, then where you slap it all in and put it in the oven and cook. It's a bit more complex than that, right?
Yeah, that's it.
Yeah.
That's it.
Still, Achille, I can't actually believe that you made these back in 1987. It's hideous looking back now, right?
You see, you're great. You're great.
So I think the key point here, everyone, is the fact that it comes back to, because there's so much complexity in the production process. That's why a helmet is a little bit more expensive than it was 30 years ago. So from there, Met will create a mold at a significant amount of money. And then the guys in China will create a batch of pre-production helmets which go to testing. So as you can see, an incredible amount of testing goes on here in northern Italy. And what sets Met Bluegrass apart from many other brands is that they actually do that testing versus on-screen calculation, which is actually done by a large percentage of mountain bike helmet manufacturers. Obviously, Met do the on-screen calculation as well. Obviously, got the real-world testing from the athletes. I mentioned Vinny T earlier. This is Jay Vine's helmet from UAE Emirates team, the road team. This is fresh off the hill. This is a massive crash that he had. So, it introduces the seriousness of concussion into the equation too.
We have different impacts on the helmet to be considered. We have the linear, we have the rotational, and the combination may affect differently on the head during an impact. There are massive crashes, accordingly purely linear situation that are maybe creating less concussion causes than rotational testing. So that's the reason for which we are implementing empiric and numerical approach in making analysis in linear testing, accordingly different standards. And we are recently adding also NTA, that is SPLC high-speed bikes, as well as the ASTM, that is downhill and BMX racing approach. We also added different approaches into rotational testing accordingly MAPES protocol as well as Virginia Tech. The combination of this plenty of certification and validations allows to make helmets safer, like in the case of the Vanguard. We have plenty of certifications such as 6 different, such as the CE, the NTA, the ASTM, the CPSC, the Australian, and MAPES validation and Virginia Tech validation. So
that's a lot of
7 different applications.
That's a lot of paperwork to go through, right?
Yeah, quite a lot. Yeah.
I think, I mean, what you said there, you know, we talked earlier about the fact that Vinny T had that massive crash in Rampage, didn't have any concussion, yet he had a smaller crash back at home in France, and he had concussion. So it's an unpredictable business, isn't it?
It's rather complicated. Even from a medical point of view, it's something that needs to be investigated, because sometimes really a linear acceleration, even if the energy and the impact is higher, can do less than a rotational impact acceleration on our skull. So that's the reason we are investigating both the cases with an approach that is trying to cover high speed as well as rotational field of application and the impact.
Wow, thanks, Matteo. I think, folks, it's really reassuring to know that, you know, companies such as Met is going through, you know, all those levels of research and testing to protect our heads. And I think just maybe like Walter off Breaking Bad, they've definitely got the formula right. Thanks, guys.